Changing the angle of a ramp's effect on height. In the first case, the angle is 5 degrees. In the second case, the angle is 10 degrees. In both cases, the height from the table to where the cart reaches is about 20 centimeters. This is because of the conservation of energy, which is further explained later. 1 over 2kx squared is equal to mgh. K, x, m, and g are all constant. K is the spring constant, x is the distance the spring is compressed, m is the mass, and g is the gravity. Therefore, the height would also be constant. This is also shown in the video below.
Materials. Ramp. Rubber object to adjust height of ramp and end stopper. Angle indicator. Metal rod. Cart or pass car. Meter stick.
Below. Procedures. Take the metal rod and the rubber object used to adjust height of ramp and the end stopper and position it with the ramp so the ramp is on an incline. Using your device to measure the angle of the incline, find the angle of incline of the ramp. Once you have your setup ready and have found the angle of your incline, you place your car at the very bottom of the ramp where the stopper is and push the button on the cart. Measure the distance it was compressed as well as the height from the table to the car when it reaches its maximum displacement. Once you've gotten data from your first angle, using a rubber stopper to adjust the height of the ramp, set it on a different incline and repeat steps 2 and 3. Record this data so you can find out what effect changing the angle of the ramp had on the height. Essential understanding. Using all these formulas, we can tell that the formula would look like this. Initial 1 over 2 mv squared plus 1 over 2 kx squared plus mgh is equal to final 1 over 2 mv squared plus 1 over 2 kx squared plus mgh. Since the beginning and final velocities are equal to 0 in the spring mass system, the kinetic energies cancel out, so you're left with initial 1 over 2 kx squared plus mgh is equal to final 1 over 2 kx squared plus mgh. The initial gravitational potential energy is equal to 0 since the height is 0 at the initial position. The final elastic potential energy is equal to 0 since the displacement of the spring goes back to equilibrium in its final position. That leaves you with 1 over 2 kx squared is equal to mgh, or the elastic potential energy is equal to the gravitational potential energy. Social studies connection. Robert Hooke was born in 1635 and died in 1703. He was the last of 4 children, and when his father died, he was left with a lot of money. Using this money, he secured a spot as Robert Boyle's assistant. Later, he came up with the Hooke's law of springs. Hooke's law states force is equal to the negative spring constant times the maximum displacement, or F is equal to negative kx. This formula eventually led to the elastic potential energy formula. Hooke first stated his law in 1660 as a Latin anagram. English connection. Here is my English connection. I chose to do a narrative essay, and it's explaining about my struggle to get good grades in physics, and when I finally did, how my hard work paid off. The end.